Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving construct the lexicographically largest valid sequence. So the problem states that we are given an integer n and we want to find a sequence that satisfies all of these conditions. So one is that the integer 1 will only occur once in the sequence, and every integer from 2 to n will occur twice in the sequence. And lastly, for every integer I between 2 and n, the distance between the two occurrences of I is exactly I. So like between 3 and 3, the distance has to be 3. Between 2 and 2, the distance has to be 2. And this line is basically saying the same thing. The distance between two numbers on the sequence a of I and a of j is the absolute difference of their indices, so j minus I. So yeah, index 3 minus index 0 is 3, index 4 minus index 2 is 2. Now lastly, we want to make sure we return the lexicographically largest sequence. So lexicographically largest just basically means that in the first position where the two sequences differ, the number with the larger lexicographical sequence is the larger one. So if you look at these two, right? 0190 and 0156. 0190 is greater because 9 and 5 is the first number where they differ, and 9 is greater than 5. So if you look at this example, this is lexicographically the largest way we can order the sequence because we start at 3 and we move 3 over, and then next we put 1, which also satisfies this condition, and then 2 and 2 where the distance is 2, which also satisfies this condition. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can have a starting resulting array and a starting used array. And the resulting array, it would be an array of zeros, and the length of it would be n times 2 minus 1. So for this example, the length would be 5 because 3 times 2 minus 1 is 5. And for the used array, the length would be n plus 1. So for this example, it would be 4 because 3 plus 1 is 4. So the resulting array would be the sequence that we are trying, and the used array will just tell us which numbers have been placed in the sequence already, where the index of it represents the number. So this index will tell us if 1 has been placed in the array, this index will tell us if 2 has been placed, and this index will tell us if 3 has been placed in the array. And since we want the lexicographically larger sequence, we will start by 3 first and then work our way down to 1. So we will place 3 here, and then we will test 2 at the next place, and if it doesn't work, then we will try 1, and then we'll just continue this sequence until we have found a sequence. So I think it'll make more sense once I go over the example. So let's go over this example right now. All right, so at the first index, we will try 3, and we need to add 3 also where it's 3 distances apart. So we add 3 here, and that works. So we need to set 3 to true, so we know that it's used. So now we get to the next index. Since 3 is used, we try 2. So place 2 here, move it 2 distances, but since this place is not 0, we cannot use 2. So we need to try 1. So now we try 1, it works. And since we only need 1 instances of 1, we don't need to place 1 over here, but we need to make sure that this is used. And then we move over to the next index. Since 3 is used, we try 2, place 2, and then we also need to place 2 distances apart, and then we need to set this to true. And then we move over to the next index. Since this index is not 0, we move over again. And since this is also not 0, we just move over again. And now that we have come to the end, this is the sequence that we return. So the time complexity of this problem would be O of n factorial, because we will have to loop through the entire resulting sequence, but at each next iteration there will be one less number that we have to try, so that's why it's n factorial. And the space complexity would be O of n, because the length of the used array will all depend on n space. So now let's get to the coding part. So first we'll make a helper function. We'll call it find. Self and cur will be the index. Result will be the resulting array, used to be the used array that we saw earlier, and target would just be n. So if current is equal to the length of result, meaning we have come to the end of the resulting array, then we can return true. And if the resulting array, the element in that index does not equal to 0, then we can just go to the next index. So return self.find current plus 1, and the resulting array, used array, and the target. So now we can have our for loop, right? So for place in range, so place would be the number that we place, and we want to start trying from target where n the largest, and then we work our way down to 0. So if use place, meaning the number is already used, then we just continue and skip it. Otherwise, we need to set it to true. And then we can edit the resulting array. Occur equals place. And so if the number is 1, if the number we want to place down is 1, then we can just move to the next index since we don't have to worry about placing another one. So yeah, just recursively call it, and if that's true, then we return true. Otherwise, if it is not 1, then we need to check if we can place it on another place, and that would just be adding the number by itself's index. So current plus place, we gotta first make sure it's less than the length of the resulting array, and then check if that place is open. If it is, then we will edit the resulting array. So result of current plus place is equal to place now. And then we can recursively call it again. And if that turns out true, then we can return true. If the recursive call ends up not working out, then we need to set that place back to 0. So set to 0. And then in the end, we set the place to 0 and user place is false if it ends up not working out. False, and we return false at the bottom. So now we can set up our main function. So result is 0 times 2, 2 times n minus 1, or n times 2 minus 1. And then the used array, it will be false times n plus 1. And now we can set up our recursive call, so self.find. The starting index will be 0, resulting array, used array, and n. And then afterwards, we can just return result. So return res. Okay, let's see if it works. Okay, perfect. Hope this was helpful. Thank you for watching. If you have any questions or comments, feel free to leave in the comments section, and I hope to see you all again soon.